Welcome back, guys. So this is a very interesting question. We have previously solved question number 47, in which we have converted each of the number here to their BCD equivalent. Okay. In question 48, we are asked to convert each of the decimal number in problem 47 to straight binary. Okay, and compare the number of bits required with that required for the BCD. So now we have to convert these number to their binary counterparts, and we have to see that how many number of bits will be required here in the straight binary and in the BCD, and what is the conversion and what are the number of bits for each of the conversion here. Okay, so previously we have seen that for the AND digit decimal number, the number of bits required for the BCD will be 4 and 4 multiplied by n. Okay, so suppose here we have 2 digits, so how many number of bits will be required in BCD? That would be 8, because 4 multiplied by 2 is 8. Similarly here for 3, I will have 3 multiplied by 4, so that will be 12. So that is the conversion here, and we can see that the minimum number of bits here will be 4. So here converting these number to their binary counterparts and seeing that how many number of bits will be required, let us see here. And for converting it, I am going to use the sum of products method. Okay, so in this method, what I have to do, let me write here 2 0 2 1 2 2 2 3 2 4 2 5 2 6 2 7. Okay, so in order to convert this 10 into the equivalent binary number, what I have to do, I have to see that in which range does it lie. So 2 raised power 3 is 8, and this 2 raised power 4 is 16, so it lies in between them, and I have to choose here the lowest number here, so lower number here, lower limit here, so that would be 2 raised power 3. So let me write it here, this one. Okay, and after a 2 is left, so 10 minus 8 is 2, so therefore I have to use this one. So here I will have 1 0 1 0. Okay, so this is the binary equivalent of my number 10. Okay, so in binary I have, for binary here I can see that 4 bits for binary. Okay, and here I can see that I have 2 digits, so 4 multiplied by 2 here is how much? That is 8. So 8 bits for binary coded decimal. Okay, so 4 bits for the binary and 8 bits for the BCD. So we can see that here the lower number of bits will be required for the binary conversion. Okay, similarly let us now go towards this 13. B is 13, so now let me convert it to the binary as well. So again I can see that this 8 is the lower limit. It basically shows me the lower limit here, because 2 to the power 4 is 16, which is higher than that. So 2 to the power 3, and how much is left? 5 is left, so therefore I'm using this one. So this is 4 plus 8 is 12. 12 plus 1 is 13. So again I am getting 4 bits for binary. Okay, and here for BCD we can see that here we have 2 digits, 1 and 3. So therefore 4 multiplied by n, or 4 multiplied by 2 is 8 bits for BCD. So for BCD I need 8 bits, while for the straight binary, I need how much? I need basically 4 bits. So that is the conversion here. Now let us proceed toward this C. So C is 18 and converting it to the binary, what I have to do, this is 16, this is 32, so I have to choose this 16 because it basically illustrates the lower limit. So 1, okay, this is now 2 to the power 4 is 16, so 2 is left because 16 plus 2 will be 18, so therefore I am choosing this one. Okay, so all others will be 0 here. So 1 2 3 4 5, so 5 bits for binary for 18 in decimal. Okay, but the for BCD we can see that the total number of the digits here we have are 2, which are 1 and 8. So therefore 4 multiplied by 2 and the 8 bits will be required for the BCD here as well. Okay, so again for straight binary we need lower number of bits, which are 5. Okay, now going towards the F, because here this 21 25 will also be like this one because these are lower than 32. Okay, so therefore the for D we will also need a 5 bits, for E we will also need 5 bits for the straight binary, while these two are the 2-digit decimal number, therefore we will need 8 bits for the BCD. While for F we have here 36. Okay, so now let me convert it here. So for 36 I can see that 2 to the power 5 is the lower limit, so this is now 1 and 2 to the power 5 is 32, so this is 32, and here let me write here, this is F and this is 36. So 32, and how much is left? 4 is left, so let me write here 4, and this is now 36, all others will be 0. Okay, so how many bits do I have here? So 0 1 2 3 4 5 6, so 6 bits are required for the 36. Okay, so 6 bits are required for 36, and again we have here 2 digits for the decimal, so the number of bits for the BCD will remain same, which are 8 bits here. So because 4 multiplied by 2 are 8. Okay, similarly here for 44 the same number of bits will be used because this is also in between 32 and 64, so 6 bits will be used. For 57 again 6 bits will be required, while for part I, let me solve here. Okay, this is now 69. So now for 69 I can see that 2 raised to the power 6 is 64, while 64 possesses the lower limit here. So 64 is 1, and how much is left now? 69 minus 64 is 5, so therefore this 2 raised to the power 2 and this 1 and all others 0. Okay, so 1 2 3 4 5 6 7, so 7 bits are required for the 69 for straight binary, while we can again see that 6 and 9 are the 2 digits, and 4 multiplied by 2 will be the required number of bits for the BCD, so therefore it will remain same. So again we can see that for 69 as well 7 bits are required for straight binary, while 8 bits for the BCD. Okay, similarly for 98 we will see that, let me write here 98, and we will see that for 98 let me convert it to the binary as well. So this 2 to the power 7 is 128, this is 64, so 64 here, 64 plus 32 is 96. Okay, that is now 96, and 96 plus 2 is 98. Okay, so how many bits are required? So again 7 bits are required for the 98 as well. Okay, because 1 2 3 4 5 6 7 bits are required for the 98, while the same 8 bits are required for the BCD. Okay, so we can see here as well. For 128 let me write for the 128 here as well. Now for 128, what you have to do, this is the 125. What we have to do, this is 2 power 7, this is 128, this is 64. So I have to choose is 64 plus 32, 96. 96 plus 16 is how much? 96 plus 16 is 112. Okay, 112 plus 8 is 120. Okay, 120 plus 4 is 124, and then 125. Okay, so these are the number of bits for what? For 125. Okay, so 1 2 3 4 5 6 7 7 bits for the straight binary, while here we have 125, and we can see that here we have 1 2 3 digits. So therefore I have to write here 4 multiplied by 3, because n will be the number of the digits which are available in the decimal number. So therefore 12 bits will be required for converting it to the BCD. Okay, so in BCD we will need 12 bits, while in the straight binary we will need 7 bits. Okay, so that is the difference here. Now writing it for the part I here. Okay, sorry, part K here, part L here, 156 is here. Now converting it to the binary, let me write here. So now here we can see that 2 raised power 6 is how much? That is 64, but 2 raised power 7 is the 128. So I am going to select this 128. Okay, so 156 minus 128. So 28 is left now. So for selecting 28, now let me use this 16. Okay, 16 plus 128 is 144. Okay, 144 plus 8 is how much? That is 152. Okay, 152 plus 4 is 156. Okay, so that is the number. Okay, so how many bits are used here? So 1 2 3 4 5 6 7 8. So 8 bits are required for converting 156 to the straight binary, while we can see that 1 2 3 digits are available here in this decimal number. So therefore the number of bits here will be 4 multiplied by 3. So 12 bits will be used for the BCD, and again we can see that straight binary will consume lesser number of the bits as compared to the BCD. Okay, so that's it for today, in which we have seen that how straight binary numbers consumes lower number of bits as compared to the BCD counterparts, and in this question we have proved the same procedure. So that's it for today, and I will see you with some more examples and some more solutions in our upcoming video. Thank you so much.